third trip, you make a ramp from first floor to second floor and you carry that on. Let's see that during which trip did you perform the most work? When you're talking about the work, it doesn't matter what you do, it's just you look at the initial and final position. Okay, because the work here you do from floor 1 to 3 is positive, and from floor 3 to 2 the work is negative. Kind of the overall will be from work from floor 1 to 2, right? The same thing for here, doesn't matter, you just take this one for a ramp or take it straight up. It's your delta H changing, right? From the 0 to some place. Change in energy, gravitational energy. Uh, it's work. And change in gravitational energy is the energy gravity final minus initial. Since the initial point and end point for all of these trips the same, we'll have the same work for all of this. Is that good? Now here, a force F is at the angle theta above the horizontal. Is the force applied. The weight, heavy suitcase of the weight mg, distance d, so the displacement is d. Along the level 4, the constant velocity we have, the coefficient of the friction between the floor and a suitcase is mu. The work done by the force F is, so I want to find the force, the work by force F. The work is what? Force multiplied by displacement multiplied by the cosine of the angle between them. This is my force applied. So instead of the force, I put force applied. Displacement is displacement. And the angle between the force of applied and displacement is theta. So simply that's the equation, right? It didn't say what is the total work. If it asks for total work, I should find the work done by frictional force and add all of this works together. Hmm. Okay. Now here is another question. The force F is applied in horizontal to 10 kilogram block, moves constant speed, 2 meters per second across the horizontal. The coefficient of kinetic friction between a block and a surface is 0.5. The work done by force F is in 1.5 minutes. Okay. I do not know the force of apply, right? But I know this is moving with constant velocity. I know the total force is equal to ma, just two forces acting on the object in horizontal. There's force of apply minus force of friction. No, that's going to be 0. Therefore, the magnitude of the force of apply and magnitude of force of friction going to be the same. Since I know the force of friction going to be mu f of n, and f of n is mg, I can calculate, I have mu, I can calculate force of apply. Okay? So I know the work is force multiplied displacement cosine theta. Okay, so you got a force, but you don't know the displacement. Maybe you need to use some kinematic to do this. Do we know the distance? No. Since this is constant velocity, velocity is displacement over time, right? Velocity is 2 meters per second. Time is 90 seconds. So if I need a displacement or d is 180. Now we have d. Put it there. Since the force of apply is forward, displacement is so forward, angle between displacement and force apply is 0, so cosine of 0 is going to be 1. Just need to multiply these two number and that would be joule. All right. Now, third question, we have a three cards, different mass on the top of them. The same force applied to each card. They move equal distance. Uh, case is more work done by force F. Okay. Since you know that the work is force multiplied displacement cosine of angle between force and displacement, the force in three of them are the same. Displacement are the same because they are moving the equal distance. So therefore, for all of this card, they experience they have the same work done with them, right? Just need to look at that. Let's see. Now, the same force is applied to each card. They then again move the same distance. Each card will have more kinetic energy at the end. So since I know that kinetic energy is half m v power 2, and since it's at the end, it's gonna be v final power 2. Uh, can I find the v final, compare them? Yes. Now, if you just know the work is changing kinetic energy, because previously we came to the conclusion that the work is the same for this three card, right? Now I know the work is equal to changing kinetic energy, half mv to final minus half mv to initial. For all of the card, they start at rest. So W is 1 over 2 mass v final power 2. Just rearrange it for v final. Okay, so that would be my v final. Then put that in this equation. Okay, and you put that in equation. You bring the m inside the square root, become m power 2. You just cancel m power 2 and m. So you have an m here. Now, since heavier it is, you have more kinetic energy. So the third card is heavier. That's why the third card possesses more kinetic energy at the end. Any question?
No, thank you. That was all good.
Okay, you're welcome. Now, the same force applied to each card and you move equal distance. Which card will move faster at the end? So we find a V final in this step, right? Heavier the mass is, you have a lower V final. So lighter it is, sorry, lighter, lower M means higher velocity. Is move faster means the one is lighter. The first card was lighter, right? Now you have a force displacement graph, and you know the area under the force displacement graph will give you work. And this is the reason, because the work is force multiplied by displacement. Now, I was just asking what is the total work? Just need to find the area, height multiplied by base divided by 2. I did it here, that's 150, which is closest to that. I think I need to change this one. 150, this is one to be correct answer. What is the velocity of the object at x equal to 6 meter? Since I know the work is changing kinetic energy and velocity as beginning, see initially at rest. Velocity at the beginning is 0, so, and I got the work here from the previous step. I have mass, so I can rearrange for V final, which is 12.247, and that would be your answer for V final. Got it?
Yeah, so your V final is 0.